I'm taking two similar questions from the chapter surface area volume. First question says a solid sphere of diameter 6 centimeter is dropped in a right circular cylindrical vessel partially filled with water. And the diameter of the cylindrical vessel is given 12 centimeter. If the sphere is completely submerged into water, so the question is how much will the level of water rises in the cylinder? So what we should do is to make a cylinder first to understand it. I made a cylinder. Let's say these are its circular bases. And then it has water to some level. Let's say the water was present up to this height, right? Let's say this was the level of water initially before the sphere was dropped. And then what we are going to do is to drop one sphere inside it. So let's say I take one circle and say this is a sphere, right? And this sphere is dropped into this so that it is completely submerged into the water. It is completely submerged. Now, what is expected to happen that whatever this level of water was there, right? You know that this was the level of water. The level of water will rise. The new level of water has to be more than this. So let's consider the new level of water is say this. Now, we know that this is the rise in the volume of water. Whatever is the rise in the volume of water has taken place. This is what? This volume of water, as you can see in this volume of water should be equal to what? The volume of this sphere. Right. So this is the concept behind doing this question. Now check here, what are the dimensions? We know the dimension of the radius diameter of this sphere. So I can take the diameter as 6. So the radius will come as how much? This would come as 3 centimeter. And if I see that vessel, which is cylindrical, and its diameter is how much? We are given 12 centimeter. So if I take this P, the radius that using capital R is going to be 6 centimeter. And what we have to find out is the rise in the level of water. That means this is what we have to get. This is H dash, say from here to here. Right? This is the height which we have to find out from here till here. Now, what you can see that the rise in level of water is actually in the shape of a cylinder, right? This you can see here. It's in the shape of a cylinder. And this being sphere and their volume are equal. So we can equate their volume. The volume of the volume of water over here is same as the volume of water over here. Now, what we can do is to equate by, after equating, we are going to write down the formula. As you can see, the radius is uniform throughout, right? Let me once again show you what I mean to say that the radius over here is throughout is going to be same. So whether it's a radius over here or here, it's all same. So we'll say that the volume of this cylinder, which is what? Pi r square. H is what I have taken as H dash. And volume of a sphere is what? It's 4 over 3, right? 4 over 3 pi. And the radius I took as small r. So it's small r cube. Now I can see that this pi and pi get cancelled. We know the radius here as 6. So we are going to write here as 6 into 6 multiplied by H dash is equal to 4 over 3 multiplied by r cube, and r is 3 over here. So it's 3 into 3 into 3. Further, I can see that this 3 get cancelled and we can reduce it further. Say I'll get H dash over here. It should come as what? 4 into 3 into 3, and that divided by 6 into 6. So it can be reduced like 3 1 times, 3 2 times, and 2 1 times, 2 2 times. Similarly, we can cancel this 2 times and this get cancelled. So in fact, it was, if you see, it was 9 into 4, 36. So we got H dash, right? So the rise in the level of water, H dash is how much? 2 centimeter. Now this is how we got the answer. That is the rise in the level of water is how much? 2 centimeter. Now let's check the other one. Now, in the second part, very similar to the previous question, it says a sphere of diameter 12 centimeters. So we know that radius of that sphere is 6 centimeter this time, is dropped in a right circular cylindrical vessel which was partially filled with water. If the sphere is completely submerged in water, the level of water in the cylinder rises by 3 centimeters. So this time we know what is the rise in the level of water, that is say H dash as 3 centimeter. What we have to find out in this case is the diameter of the cylindrical vessel. That means this time we have to find the diameter, right? This is what we have to get. Now, concepts remains the same, that here also we will be equating the volume of this cylindrical rise in the level of water with that of the sphere. And let's check here. If I equate, this is cylinder whose volume is pi. R I have taken as what? Let's say I take capital R over here. So this is pi R square. H is H dash is equal to, for sphere, it is 4 over 3 pi R cube, and R is small. R is what I have taken. So pi and pi get cancelled. So we have this R square is what we have to determine. H dash is 3 right over here, is equal to 4 over 3, and this radius is how much? We have this radius as 6. So 6 into 6 into 6. So this can get cancelled by 2 times, and I can cancel this 3 with this 6 with 2 times. Check what we are getting. R square as what? We have on the right hand side 4 into 6 into 4, right? This is 4, that much. So R square comes out to be what? This is 16 into 6, right? That is 96. That should be 96. So R comes out to be what? Under root 96. So we can do one thing. We can factorize here also as not a perfect square. The square root of 4, right? I can write like this. This is 4 into 4 into 6. That means the square root of this. So what we are going to get here, we are going to get R as 4 will come outside. So it's 4 root 6 centimeter is what the radius. But then we have to get diameter. As you know, diameter is twice the radius. So we'll write down the diameter as 2 times of this, which is 8 root 6 centimeter is what the diameter. That's how we'll do this question.